UART, or Universal Asynchronous Receiver Transmitter, is one of the most used device-to-device communication protocols. This shows how to use UART as a hardware communication protocol by following the standard procedure. When properly configured, UART can work with many different types of serial protocols that involve transmitting and receiving serial data. In serial communication, data is transferred bit by bit using a single line or wire. In two-way communication, we use two wires for successful serial data transfer. Depending on the application and system requirements, serial communications needs less circuitry and wires, which reduces the cost of implementation. Communication protocol plays a big role in organizing communication between devices. It is designed in different ways based on system requirements, and these protocols have a specific rule agreed upon between devices to achieve successful communication. Embedded systems, microcontrollers, and computers mostly use UART as a form of device-to-device hardware communication protocol. Among the available communication protocols, UART uses only two wires for its transmitting and receiving ends. Despite being a widely used method of hardware communication protocol, it is not fully optimized all the time. Proper implementation of frame protocol is commonly disregarded when using the UART module inside the microcontroller. By definition, UART is a hardware communication protocol that uses asynchronous serial communication with configurable speed. Asynchronous means there is no clock signal to synchronize the output bits from the transmitting device going to the receiving end. The two signals of each UART device are named transmitter or TX and receiver or RX. The main purpose of a transmitter and receiver line for each device is to transmit and receive serial data intended for serial communication. The transmitting UART is connected to a controlling data bus that sends data in a parallel form. From this, the data will now be transmitted on the transmission line, or wire, serially, bit by bit, to the receiving UART. This in turn will convert the serial data into parallel for the receiving device. The UART lines serve as the communication medium to transmit and receive data from one device to another. Take note that a UART device has a transmit and receive pin dedicated for either transmitting or receiving. For UART and most serial communications, the baud rate needs to be set the same on both the transmitting and receiving device. The baud rate is the rate at which information is transferred to a communication channel. In the serial port context, the set baud rate will serve as the maximum number of bits per second to be transferred. The UART interface does not use a clock signal to synchronize the transmitter and receiver devices. It transmits data asynchronously. Instead of a clock signal, the transmitter generates a bit stream based on its clock signal, while the receiver is using its internal clock signal to sample the incoming data. The point of synchronization is managed by having the same baud rate on both devices. Failure to do so may affect the timing of sending and receiving data that can cause discrepancies during data handling. The allowable difference of baud rate is up to 10% before the timing of bits gets too far off. Thank you for watching till the end. I hope this video helped you to understand UART. I will provide more information in upcoming videos. Do comment and share your ideas, whatever you want, comment anything.